Hi again, everybody. Here's another type of problem that we need to be able to do using the mid-segment. You'll notice, of course, there are no coordinates in this problem, so there's no real, quote-unquote, formulas to use here. But we do need to understand the relationships. For instance, the first question asks about Vx, and Vx is right here. Vx is a mid-segment because you see the tick marks for Hx and Jx. So this is these two are congruent, meaning x is in the middle. Similarly, V is in the middle of GJ because GV and VJ are the same. Okay? So without them actually telling you this is a mid-segment, you should be able to get that from the picture. So if this is a mid-segment, we know it relates directly to this side of the triangle in a very special way. Really in a couple of special ways. One of the special ways deals with its length. And looking at the question, if 8 is looking for the length of Vx, I would really like to know the length of GH, which we do. GH is 46. The mid-segment is always half the length of the side that it's parallel to. So if this is 46, I know instantly that Vx is 23 without having to do any real formulas or anything. I mean, technically, you could take a step and write xv equals 1/2 GH if you really wanted to show it, and then xv equals 1/2 of 46, so xv equals 23. Now that's a little bit of overkill, but if you're not sure where this 23 is coming from, maybe this is a good idea for you. Okay, look at HJ, same idea. HJ is this one here. Okay, HJ is right here. Well, that relates to this mid-segment drawn from W to V. Again, it's a mid-segment because V is the midpoint, W is the midpoint because those are the same, so this segment is half of this whole thing. Sorry, I don't know, I got a little carried away with the coloring in there. So this segment is half of this segment here. Well, I don't know what this one is, but I definitely know this one, it's 27. If this is 27 and I want to go up to the longer segment, well then I just take that 27 and double it. So this has got to be 54. Done. It's that simple. The hard part is when they're kind of all mixed into the same picture, it's hard to really visualize. So maybe it's a good idea to use, different colors or, redraw it separately with just that part. What if we redrew this triangle over here with just this part? What if I only drew it this way and I put 27 here and I said solve for, that? Right? That wouldn't be, as difficult probably to see as it is here, but it's the same exact problem. If this is 27, this has to be 54. Done. If this was 54, you could have figured out that was 27. Same idea. Okay, that's a 54. All right. Then it asks you for an angle, which seems to kind of come out of nowhere, but it's not so bad. Angle VXJ. Angle V, where was X? I assume that's here. VXJ is right here. I kind of drew over the X a little bit too much. So VXJ. Well, this mid-segment, the red one, is parallel to the blue side of the triangle. These are parallel. That's one of the properties of the mid-segment theorem. And since these are parallel, you can think of HJ as a transversal. Okay, if I were to redraw that separately, let's draw that over here. Parallel line, right? I'm sorry, that's the transversal. Transversal, parallel line goes this way, parallel line goes this way, and they want to talk about this angle and some other angle in the picture. Well, the only angle they really gave us is the 92, but even if they didn't just give us that one, hopefully you can see that those two do match up, right? Those two are the same as these two. The question is, do you remember what these two are called? And if you followed the notes from class today, you probably heard those are corresponding. So, since these lines are parallel, corresponding angles must be the same. When if this is 92, well then I guess that one's got to be 92. Done. That's it. XJ. XJ is this little piece right here. Let's call this, I don't know, let's call it little z. Okay? So from X to J. Well, we already know HJ is 54, right? And these two pieces have to be the same. So if X is in the middle of the 54, well then I guess each of these has to be 27. Alright, so you just really put the pieces together based on, the different properties we learned, but there's no coordinates, there's no formulas, there's nothing like that. Okay? If you need any help with a problem like that, just let me know, post it on Edmodo, and I'd be happy to help. One more problem we'll try together. And I think this one is causing some people some grief. I did not at least get to one like this in class, so if you're having a little trouble with this, let's talk it through. The good news is it's really very much like what we just did. The only difference is there's a little bit more algebra involved. So let's focus our attention on the pieces they're giving us. UW is right here. That's UW. And YZ is this one right here. And they're telling us that UV and W are midpoints. So I immediately know that this is a midsegment, which means it's parallel to this side, and it's got to be half its length. And I know that UW is 4x minus 1. So 4x minus 1. And I know that YZ is, YZ is 5x plus 4. Now, if this was like the problem we just did and it was like 27, I don't think anybody would have too much trouble telling me, oh, I guess this is 54. The problem is it's all just with x's. The good news is if you understand how we got from 27 to 54 from this problem, right, to go from 27 to 54, we had to multiply by 2. Well, we're going to do the same thing here. I have to take whatever this is and double it in order to make it equal this one. So I have to take 4x minus 1 and double it if I want it to catch up all the way to what this one is. And that's the equation you have to do. Now, some of you might be thinking, but Mr. Miller, I thought you said this is going to be half of that one. Well, that's fine. If you want to do 4x minus 1 equals 1/2 5x plus 4, we're going to get the same thing. Okay? It doesn't really matter which way you do it as long as you come up with a consistent way that works, or that makes sense. So this becomes 8x minus 2 equals 5x plus 4. Bring the 5x over, that's 3x. Bring the 2 over, that's 6. So x must be 2. Okay? So I subtracted 5x to get the 3x. I added 2 to get the 6. Then divided by 3, I got 2. That's just basic algebra 1. Hopefully that's okay. And if x is 2, let's double check. Make sure we can get our values right since they did ask for UW. This is going to be 4 times 2 minus 1, which is 7. This is going to be 5 times 2, which is 10, plus 4, which is 14. 14 is double 7. I know I did it right. Okay? So a very similar problem to what we did here, just with a little bit more algebra involved, but it's basically the exact same concept. Okay? Hopefully that helped. Of course, again, if you have any other questions, please don't hesitate to post on Edmodo, and we'll try to help you out. All right? I'll see you later.